So, Robert, you're saying error handling, while necessary, can actually hurt clean code?
Exactly, Andrew. It's like a side dish that can become the main course. If you don't manage it properly, it can swamp the actual recipe.
Can you give us a real-world example?
Sure. Imagine a web app. If every single line of code checks for every possible error, the code becomes a spaghetti mess. It's hard to follow the actual logic of what the code is supposed to do. It's buried under error checks.
So there's a balance to be struck?
Absolutely. Robust error handling is crucial, but it shouldn't come at the expense of clean code. We need error handling that doesn't obscure the logic.
What are some techniques for striking this balance?
Well, using exceptions for unexpected errors and logging for more general conditions. Limiting the level of checks to the core logic can help.
What about preventing errors in the first place? Is that part of clean error handling?
Absolutely. Preventative measures are key. For example, validating user input, making sure you're not going beyond array bounds. That's a great way to prevent errors before they happen.
So, how do we quantify obscuring the logic?
That's tough, Andrew. It's more of a judgment call. Look at the code. Does it feel overly complex, hard to understand? If so, it probably needs a different approach to error handling.
So, you're saying that error handling is about efficiency and effectiveness?
Yes. It's about making your code graceful under pressure, without drowning in code trying to anticipate every possible error.
Okay. Thanks, Robert. That makes a lot of sense. Robert, you've talked about writing clean code. But how do we handle errors in a way that doesn't clutter our code and actually improves readability?
Absolutely, Andrew. One crucial aspect is using exceptions instead of error codes.
Exceptions? Can you explain that?
Sure. Imagine you have a function to shut down a device. Using error codes, the calling code needs to constantly check for errors. It makes the code more complex and harder to follow. Throwing exceptions, on the other hand, lets you separate the error handling from the actual logic of device shutdown.
That sounds cleaner. But aren't exceptions slower?
Well, there's a performance trade-off, but usually, it's not significant. Modern languages are well optimized. The real gain is the readability and maintainability improvement. You're focusing on the task, not error conditions.
But what if performance is absolutely critical? Are there situations where return codes are better?
You are absolutely right. In highly performance-sensitive situations, like embedded systems or real-time applications, error codes might be more efficient, because exceptions often involve extra overhead in handling the exception object. Plus, the code might be more readable than exceptions where there is a huge number of possible errors.
Okay, so exceptions are generally better for readability, but return codes might be faster in certain cases.
Exactly. You want to choose the tool for the job, but in most cases, exceptions are a powerful, maintainable, and clean solution.
So, you're saying exceptions promote cleaner code?
Exactly. The code is much more focused on what it should be doing rather than all those error checks. It's more readable and easier to understand and change over time.
That makes sense. Thanks, Robert.
My pleasure, Andrew.
Hey, Robert, so we've been talking about, writing clean code and avoiding those nasty runtime errors. Just now, I was thinking about a recent project where we had a null pass to a method, and boom, null pointer exception. It was a real headache.
Yeah, Andrew, that's a classic issue. Null pointer exceptions, they happen more often than we'd like to admit. And it's often because someone somewhere passed a null value into a method when it wasn't expected.
So, how do we prevent that? Is it just like always checking for null in every method?
Well, you could add checks everywhere, but that quickly becomes, tedious and hard to maintain.
So, what's the better way? Throw custom exceptions?
Throwing custom exceptions can work, but you then need to handle those exceptions in multiple places. It adds layers of complexity that can introduce bugs into the system itself. It can become harder for others to follow, understand, and debug.
So assertions?
Assertions are good for documenting the expected input, but they don't prevent the program from crashing if the assertion isn't met.
So, what's the real solution? A strict no-nulls policy?
Absolutely. When you forbid nulls by default, it forces you to think about where you might need to guard against it, and it's great at preventing those unexpected runtime issues when someone accidentally passes a null value. It's like building a safety net around your code.
But what about edge cases, Robert? Imagine a system where, null really is a valid input.
True, Andrew. You're right. That's a really valid point. There are valid reasons for nulls to be passed. Forbidding them by default won't work in all cases, but for the vast majority of the time, it's the cleanest approach.
So, how do we handle those valid null inputs without compromising the safety net of strict null checks?
We can explicitly handle them. It's often better to take the time to check for them separately to avoid unexpected crashes or exceptions. We can have a separate layer of validation.
Okay, that makes sense. So, it's not a blanket prohibition, but a proactive approach.
Precisely. You can make a conscious decision about when a method expects a non-null argument and what appropriate handling will be.
Thanks, Robert. This has been really helpful. So, Rober, you're saying we can write code that's both clean and robust? How exactly do we separate error handling?
Yeah, absolutely. It's about compartmentalization.
Compartmentalization?
Imagine your main program logic as a house. Error handling is like a separate room. You can design and decorate it exactly how you want, without making the house itself messy or harder to live in.
So it's like a utility closet?
Exactly. You put all the error handling, the recovery mechanisms, in a dedicated place. Then your main code flow is clear, concise, readable.
But how do you actually separate them?
Maybe use try/catch blocks, for example. The error handling code is nested, but kept separate from the main logic.
That makes sense. But what if we have lots of errors? Doesn't that make the utility room too complicated?
You could use custom exception types to classify errors. This helps in organizing and handling various kinds of errors separately.
So, you could have different error types like file not found, network issue, etc.?
Exactly. It keeps things well organized and readable within that separate error handling area.
Interesting. Real-world example?
Imagine a banking app.
Validating user input is main logic. Handling invalid input is the utility room, for instance, a database error or insufficient funds. The validation stays crisp. Handling those issues separately keeps the main logic clear.
So, you're saying that by compartmentalizing error handling, we avoid the common pitfall of mixing things, thereby maintaining maintainability?
Exactly. This compartmentalization allows us to reason about the error handling independently. This is crucial.
So it's not just about being readable. It's actually being more manageable too.
You got it.
I see. It's like modular design, but for error management. Pretty cool.
It is. It's about splitting concerns effectively.
Thanks, Rober. That's a very helpful perspective.
You're welcome.